Okay, good morning. So let's get started with today's lecture. Today we are going to learn how to solve linear programming models using computers. And we're gonna have two lectures on this subject. Today we're gonna focus on the use of Excel. And then on Monday, we're gonna learn AMPLE, which is a software that you can purchase to solve linear programming models. And compared to Excel, we would have it's more powerful in terms of speed of solution and also the size of the models that you can solve. So Excel is one of the strategies that I like to teach because I know when you go to any industry or any company, they will have access to Excel. So I know for sure you're gonna at least be able to use Excel to solve these problems. But it will depend on the company that you end up working, the type of software that they will have available. So there are multiple commercially available software. AMPLE is one of the software that is commonly used in practice. AMPLE is, well, we will talk more about AMPLE on Monday. But what I'm trying to say is there's many options, but we try to teach you the ones that are more common or popular in the industry. So AMPLE is one of them. And then there will be in other advanced courses taught by Dr. Novoa. I teach you go on learning GAMS or Learning Express, which are other two options, and also MATLAB. So let's get started. So thank you for those of you who brought your own computers. If you don't have a computer, we have some machines here, or if you experience any issues, you can have those. For AMPLE, I would like you to be aware on Monday, we're gonna start using AMPLE. So I think by the end of this week, I'm gonna post the lectures for AMPLE, and then I'm gonna provide a link for you to download that software into your computer. So if you come to class on Monday, you have the software available in your machine. If you are not able to do that, then the computers that we have here, the laptops, should have AMPLE installed. So you can either install that in your machine, or you can come to class and use one of the laptops that we have available. So today we're going to focus on solving LP problems using computers, again, using Excel. And before we get into the lecture, so by Monday, you should have your exams back. Thank you for waiting. So on Monday, we're going to be also discussing the exam, and I'm going to be passing the exams back and also releasing the grades. So the exams are graded. We are just waiting for one student that is taking the exam today, and we will be ready to discuss the exam on Monday. So let's get started. In the module for today, the lecture is available, and I also posted an Excel file that you can download that will be used today during the lecture. We also have a lab, and I'm going to explain a little bit more about what we're going to do with the lab after the lecture. So the agenda is the following. We're going to provide an introduction, and then we're going to set up a spreadsheet in Excel, and then we're going to try to solve the YAPETOS problem that we're discussing in class using Excel. So we're going to show the solution for that problem and so on. So the idea is that you get familiar with the Excel, adding solver add-in in Excel, and you see how to use that solver add-in to set up the linear programming model and then solve it using the simplex method. So I think once you learn how to set up one model, the transition to solve other models should be easy. You'll see it's pretty straightforward. How many of you are comfortable using Excel? Like, you know how to build formulas and all those stuff, right? So that's good. So if that's the case, then you should have no problem. So, so let's look at the learning objectives. Use Excel solver to solve linear programming models. And as an introduction, Excel has the capability to solve linear programming problems. Also, it is able to solve nonlinear programming problems, but those are outside the material for this class. In this lecture, we will show you how to use Excel solver to find the optimal solution to a linear programming model problem. And the key to solving an LP on a spreadsheet is to set up a spreadsheet that tracks everything of interest. So the data that is provided into the problem, we want to make sure that we set up that appropriately, so we can pull that information into the formulas and solve the model. So what I'm trying to say is there's two ways that we can build a model in Excel, a linear programming model in Excel. The easy way would be just to set up the equations in the same way that we have formulated the model. So if it is 3x plus 2x2, we set up the equation in that way. But the little bit more challenging way, I would say a little bit more difficult way, is to separate those parameters, those associated with the model, into a table, and then pull those from those parameters as needed in the formula. The good thing about that is that if we change the parameters of the model at some point, we just have to edit the table and we can solve the problem without issues. So in that way, we make sure that we have a reusable model. And I think that's what we should try to do every time. We build a model that we can reuse later on. So that's the way I'm going to teach you. You'll see that I will set up all the parameters on a separate table, everything individually, and then I'm going to build the formulas by calling those parameters from the table. That way, you can reuse those models in the future. If you just change the parameters in the table, you can reuse the model and solve for that new set of parameters. So let's set up the spreadsheet. So we want to identify the cells of interest that can be buried. These are called the changing cells. So the changing cells are going to be our decision variables. So those are the cells that are going to be changing values. And at the end, we're going to have a solution that is going to tell us this is the best you can do with the constraints that are available. So the changing cells are those associated with the decision variables. And then identify the cell that contains your objective function, and that will be our target cell. And then we're also going to identify the constraints and tell the solver to solve the problem. At this point, the optimal solution will be placed in the spreadsheet. So if you remember the YAPETOS problem, I think this is the first problem that we discussed in class. We have two toys, and they have different prices, and they have also different costs of production. And then also labor requirements are different. So we have that information. From here, we have the soldiers build for sell for $27 and use $10 worth of raw materials. And then variable cost is $14 for the soldiers and requires 2 hours of finishing labor and 1 hour of carpentry. So that's for the soldier. And for the train, we get $21 when we sell one, and that one used $9 worth of raw materials. Labor cost is $10, requires 1 hour of finishing labor and 1 hour of carpentry labor. We also have some additional information. So we have the capacity limitations for the finishing hours and the carpentry hours. And we also know that at most 40 soldiers are bought each week. So we wanted to maximize the weekly profit. And the formulation is here. We have the objective function, the 4 constraints, and the non-negativity constraints. So we also, the reason I'm using this problem is because we were able to solve this problem using the graphical method. So now using Excel, we're gonna confirm that this is the right solution. Okay, so we found that the optimal solution was X1 equals 20, X2 equals 60, and then the profit will be $180. So how do we set up the problem? To begin, create a table with the problem information. So this was what I was referring to. We want to set up the spreadsheet in a way that we can set up all the information in a separate table and then pull that information into the formulas. So here we have, the way I set it up was to have a heading for each product type and then resource availability for each product type and the demand for each product type. So let's open the Excel file. If you go to that Excel file that is available, this is what I'm referring to. Okay, let me see. Let me check. So if you go to modules, yeah, so let me just, in case someone else is facing the same issues, to go into today's lecture, October 6th, and it will be this Excel file that you can download from the modules. Yes, and it was not clear, but that .xlsx is a Excel file, and then this is a PDF file. So if you open that file, I did some of the work in this file already. So we have the data, which I'm using this pink color to highlight. And so the variables changing cells, those, since we have only 2 decision variables, those are X1 and X2. So I have those listed also separately. If you have 20 decision variables, then you have to have 20 cells identifying each decision variable. If you have 100, you have to have 100 cells. So that's why when we try to solve these large problems, setting up the spreadsheet is kind of challenging. So in those cases, we want to transition into more other type of software, which is Ample, for example, will make this easier. So for now, we have 2 decision variables, and then we have the target cell in green, that's the objective function. And then we have 3 constraints. I know the right-hand side, so I'm making those already available for you. So the right-hand side is here for constraint 1, constraint 2, and for the demand constraint is 40. So, so now we have to start building the equations that are needed for this model. Let me show you next step here. So the first thing we're gonna do is to set up the objective function, right? So I'm giving you the formula right here. We're gonna do that for real time in the Excel now. So essentially what this is doing is using the data for the selling price, the material cost, and the variable cost for each product to set up a general equation for your model. And again, the idea is now that we are, instead of just plugging in the values into the formula, we are building a general model that if we change the values in the table, we can reuse this model later on. So for example, if I increase the selling price to 35, I can just go into the table, switch 27, input 35, and then I can solve the problem without having to edit the model. So that's the idea. So let's set up this equation in Excel. So I have the objective function here. So I'm going to start with my first product, which are the soldiers. So I'm going to use the cell for the selling price, and I'm going to subtract the raw material cost and the variable cost. So that has to be multiplied by X1. Okay, so 27 minus 14 minus 10 is going to give me that profit, and I have to multiply that by the number of units of that product. And then I'm going to do the same thing for the other product. So I have 21 minus 10 minus 9, all that multiplied by that cell representing the second product. So that's my equation. So the way to verify this, once I hit, any questions? Very simple. Any questions about this? So once I hit enter, this is going to be 0 because there's no parts being produced. So if you remember, if I enter 1 here, this should be 3, right? Because that's the profit we get per unit. So this is just a verification, just making sure that this is right. And if I put 1 here, this should be 2. Okay, so the objective function is doing what it's supposed to do. But I don't know how many units I'm going to produce. So that's what the model is going to tell me. So this is the first step. Once we set up the spreadsheet for the decision variables, the information, we start setting up the equations. So we set up the equation for the objective function. Now we're going to set up the equations for the constraints. Okay, so I'm going to move to the next slide. And we're going to set up our first constraint. Right, so our first constraint is the finishing constraint. And that constraint is the number of labor hours for each product. So we have to multiply the finishing hours for soldiers and then add that to the finishing hours of the trains, and that has to be less than or equal to 100. So it is 2x1 plus 2 plus x2 less than or equal to 100. So again, we proceed in the same way. So we have the equal sign, the finishing hours, labor hours for soldiers is 2, which is in B5, and multiply that times the decision variable. So I think this is where students struggle a little bit. Remember that you have to multiply by the decision variable, and that decision variable is represented by a cell. So you have to go find that cell representing the decision variable. So you're multiplying that times the cell representing X1 plus the labor hours for trains times the cell representing X2. So in this case, we have B5 times B9 plus C9 plus C5 times C9. So if you look at the Excel and you look at the PowerPoint, they have the same formula. Questions? Yes. Oh, wait. Okay, so once you enter, you get a 0. Again, this is connected to the number of units that you have. So if you input a 1, you'll see that this should be 2. And if you input a 1 here, it should be 1. And we have to do the same thing for the second constraint, which is the carpentry constraint. Okay, so for the carpentry constraint, we're going to look at the carpentry labor hours. So now we're dealing with constraint number 2. So again, we set up the constraint with an equal sign. And now we go to the number of hours, carpentry hours, times the cell for X1. So this is X1 plus X2. So it's carpentry labor hours times X1 plus the carpentry labor hours for the trains times X2. So we have B6 times B9 plus C6 times C9. And so the cell name is not relevant, okay? But what's relevant is the information that you need to use. Like the cell name is going to be associated to the cell where the information that you need is located. So you have to make sure that you're picking up the right information. You're using the cell representing that information. So in this case, the information that we need is the carpentry hours. So for soldiers, that is B6. For trains, that is C6. So that's why we are multiplying those times the decision variables. And again, this will be 0. So far, we have no solution for the problem. And then the last constraint is just X1 less than or equal to 40. You'll see that demand for soldiers has to be less than or equal to 40. So what we are going to do there is just to make that left-hand side of the constraint equal to the cell representing X1, which is B9. Then we hit enter. So at this point, the work in terms of inputting the formulas is done. So we have our Excel file set up. It's complete. So what we need now is to, okay, how do we tell Excel that this is a linear programming model? And how do we tell Excel to go solve this using the simplex method? So that's the next part. So after setting up the formulas, we are going to deal with the installation of the solver add-in. In case you don't have it available, we're going to show you where that is located. Okay. So from the data tab, you will select the solver. So if you don't see that, if you go to data tab and you don't see the solver, you will have to install that in your machine. So I'm showing you the tab here for Excel. This might be an earlier version of the one that you have right now, but it should look very similar. If you go to data, at the last part of towards the right of the tab, there should be a analysis piece. Like if I go to mine, let's see if I have it. to data, and then you have the analysis piece here, and you see solver is showing up there. If you don't see that, I'm going to show you how to find that in your Excel. You have to install it. It's very easy to install. So if the solver add-in is not available, you will have to install the analysis toolpack in Excel. So that's what we're looking for, that option in the red, the solver. So installing the analysis toolpack and the solver add-in, you have to go to the File tab, Excel Options, Add-in, and then click Install. So you go to Options, you see here at the bottom, towards the bottom, there's a Options, and then you have the Add-ins option here. You go to Add-ins in this window, and you will look for the analysis toolpack. And then when you get there, you have to hit Go. So that Go is here, Manage Add-ins. You have to hit this Go, and that will pop up another window. So let me show you how that looks like in Excel. So if you go here, you go to File, there's options here at the bottom. So in my case, it's the last option. And then here you go to Add-ins. And you find the analysis toolpack. And then click Go. And then you're going to select the solver add-in from this window. Check this. That. So the solver add-in is here. You click there, and then you click OK. So after that, if you go to data, you should see the solver. Were you able to install it? You had it. You had it.
I didn't have it, but I will.
Okay, good, good. So now we have the solver. It's great. What we want to do now is to click on solver, and you will see this. So this window is user-friendly in the setup in terms of telling you what you need to do. So see the first option there is telling you set the objective. So that's connected to the objective function. So you're gonna click on this button, and you're gonna go find that cell for the objective function, and you're gonna click that. So in our case, the objective function is located in B11. So I want the solver to know that that's where the objective function is. And then you click enter. And then you see what we are trying to do here is to maximize that objective function. So you have the option of selecting max or min, or if you want to make that objective function specific value, you can also do that. If you want, I want that objective function to be 100, you can do that. So maximization and then changing variable cells. So here's where you're going to enter the decision variables. What's challenging here is that you have to make sure that you select them all in, like you highlight them, you select both of them in this case, and if you have more than one, you have to make sure that you select all of that range where the decision variables are located. So we have the changing variables, and now we're gonna add the constraints. So the constraints are gonna be listed in this piece of the window. So we're gonna add constraint by constraint. Constraint one, the left-hand side is here, and then we have the sign. This one is less than or equal to. And then the right-hand side of the constraint is given by this cell. So again, very straightforward. You go select the cell corresponding to that constraint. So you have the left-hand side, you have the sign, and then you have the right-hand side. So the left-hand side is the formula that we set up for first constraint, and that formula is located in B14. And then the sign restriction for this constraint is less than or equal to, and the right-hand side is located in D14. So that's the first constraint. Then we're going to click Add. And we're going to do the next one. So same thing, the left-hand side, the sign restriction, and the right-hand side. And we're going to click Add. And we have the third constraint, left-hand side, less than or equal to. Remember, you have many options here. So in our case, this is less than or equal to. And then the right-hand side of the constraint is this one. And at this point, we are done setting up our constraints. So when you click OK, you will see those three constraints showing up in the window. There's a option here that says make unconstrained variables non-negative. We want to check that because that's what's going to tell the model that your decision variables, in this case, x1 and x2, are going to be greater or equal to 0. So you want to make the decision variables non-negative. So that's why we are clicking there. If you have a combinations of greater or equal to 0 and unconstrained decision variables, if that's the case, then you have to go to the constraints and tell the model, you know, x1 is going to be greater or equal to 0. So in those cases, you're going to have to specify for each decision variable which ones have to be non-negative and which ones are going to be unconstrained. But that's not our case. So we can handle this using this option. And then the other thing, we have many solution methods, or at least 3 highlighted here. We want to use the simplex. Okay, so in our case, for this class, we're going to be using the simplex method. When you get to nonlinear programming, you would use GRG, and for problems that might be too big to be solved using the or might be a combination of integer variables, or a combination of integer and continuous variables, we can rely on other methods such as the evolutionary. But that's not our case. We're going to focus on the simplex because we are dealing with linear programming models where the decision variables are continuous. So we're going to solve this. And after you solve, you'll get a window that says if the problem was solved successfully, solver found a solution, all constraints and optimality conditions are satisfied, you can keep the solver solution, or you can restore that to the original values. You can also save the scenario. And then there are some reports here that we want to explore. We're going to look at sensitivity later on this semester. But for now, just going to click OK. And the answer report is basically telling you the final value of the decision variables and the final value of each one of the constraints. And you can see here for the third constraint is telling that we have some slack. For the first 2, there's no slack. For the last one, there's some slack. If you go to the solution of the model, you see that this is 20 and 60, which is what we found originally when we solved the problem using the graphical method. So let's see what else I have here. Any questions at this point? You say you had a question.
Yeah, so mine was going to be how we do but the quick put it and so we figured it out that way.
Yeah.
But the ones that we have there, it's just to show like visually, like constraint needs to be less than 100. It
Yeah.
needs to be less than this, and then in the solver, that's where you actually put.
Yes.
This one has to be less than or whatever it is.
That's correct.
That was gonna be my question.
Yes.
That's why I waited just to make.
Yeah, so the way I set up, the format that is set up here, is to help us visualize how the model will look like. Can I help you, sir? Oh, yeah, okay. So visualize how the model will look like, in terms of the setup. Yes,
Yeah.
yes.
So it this is shows what we did previously, but gives it like in cell form.
Yeah.
We're just putting it up that way.
So when you go into the actual solver, you know what signs are you gonna use. Yes.
Okay.
Yes, correct. So this is, yes, so let's see what else I have listed here in, so again, I think the PowerPoint is very informative in terms, if you have issues, you can return to this and we'll show you specifically what to do, changing cells, adding the constraints, how to add the constraints. So this is exactly what we did for each one of the constraints. So you should get the solver options are designed to address a specific type of problem. Like for example, simplex is an algorithm that is designed for linear programming models. So if you want to find the optimal solution for a linear programming model, you should use simplex. The evolutionary option there is a heuristic that is designed to find, I mean, the heuristic can give you the optimal solution, but is designed to solve problems in which finding an optimal solution will take a long time, like very big problems. So the heuristic will basically try to find a good enough solution if you're dealing with a big problem. If you want to find a clear solution that is good, maybe not optimal, but good, you can use the evolutionary. For our problem, if you click on the evolutionary, you will get the same solution because it's a small problem. So the heuristic will work well. And then the third option is for nonlinear programming models. So those are not the type of models that we are dealing with at this point. And that's our models that you're gonna see in one of your electives that is taught by Dr. Noboa. So let's see what else. So what I want you to try to do now is to look at that lab, see if we can work on that together before the end of the period. So lab 5 is basically asking you to try to solve the single period production model in Excel. So I'm giving you here the formulation. The best way is to go back to the model discussion that we have, I think was in lecture 3. If you want to set up this appropriately with a table, all the data, and then pull that information from the data table. So that's the lab. Let's try this. I'm gonna let you work on this for 10 minutes, and then we're gonna try to solve it together using Excel. I will set it up for you, and then we will have a discussion. And then you will upload the solution by the end of the day. So let's work on this to see how far you can go, and let's discuss that before the end of the lecture. You have a question?
Yeah. For Excel, what would be like what's the max number of
Position variables?
Yeah, like
so
let's say you have like 10, is that okay?
Yes. So Excel, the way it's designed, as it is right now, it will handle 200 decision variables, up to 200.
So you could.
Yes, you can solve up to problems up to 200 decision variables. If you go above that, there's another add-in that we can put into Excel that will allow you to solve larger problems. You know, let me pull that information and we'll make it available also in the modules. It is called Open Excel, I think. Let's see, Open Solver. For Excel. So this is an open source, got a lot of awards because it works very well. And it will allow you to solve very big problems using Excel. So I'm gonna put this there because
You would just kind of do the same thing.
it's the same strategy.
Just add it in,
Yes,
that way
it's,
like it-
you see here, there's in the data, you will have another analysis
Okay.
portion there, but the Windows looks very similar. Actually, let me try to download as when you work in this, as you're working on this, I'm gonna install it. I will show you how it looks like. But I know some of your students or colleagues in Capstone, they have used this to solve problems that are big, and it has worked very well. So I'm going to put this information in the modules. And again, it's an alternative to Ample. Some students will be little try to avoid programming, even though it's not a lot of programming in Ample, but since it requires some knowledge of coding,
Oh, yeah.
it will scare them a little bit. So they will prefer to use Excel. So it's an option. So let me put the link here.
Are we gonna be required to or every problem we solve with Excel?
You can, yeah, you will see that using Ample has advantages. Like if you are going to set up a model that is big, it will be, if you know Ample, is easier to set up in Ample than in Excel, because it will save you a lot of time, because you just input the line of code and it will build a model for you automatically. While in Excel, you actually have to build constraint by constraint, decision variable by decision variable. So open solver link.
Then you like put it in the same form, like you can like add it all like a slack variable. So I noticed that we just use inequalities in our missing Excel, did all that for us.
Yes, Excel is doing all that for you.
So we don't have to
You don't have to worry about that. But if you set up everything as equality, you should be able to get the same solution. Like if you add the slacks, you will have to define a space for the slacks in your decision variables, and then you're going to put them as the changing cells as well. So when you solve the problem, the slack variables are also considered part of the solution.
inequalities, you don't have to worry about the slack.
No, you don't have to worry. Actually, Excel will,
Because it allocates, it shows us.
yes. So if you go, it will build those, you see the slacks are showing up here.
Okay, so that would be like slack.
Yeah, slack. Yes. So you get the slack value there. Yes. All right. Close Excel. I'm not seeing the adding. I know there's an additional step that I need to do. Trying to see if I can get it to work. I'm gonna stop this, the screen sharing for a minute. I'm gonna continue sharing the screen later. So continue working with your app and now we will discuss in 8 minutes. It's not letting me. Permission to select. I'm not sharing the screen right now, so I'm gonna go back to those screen sharing in a minute. We're doing the lab. So, so Billy, I saw your comment. Working on the lab, and we're gonna go back to the screen sharing and the lecture in 2 minutes. Okay, so let's talk about this. Were you able to get a solution? Yes, no.
I'm still working on
Okay.
but I'm not sure if it's right or not.
Okay, so I have in the screen, you'll see the way I set up this problem. As I mentioned, I like to set up all the data in a separate table so I can pull the information when I'm building the constraints. So let me just take this out here.
Yeah, I didn't have the categories.
Okay.
All I did was the basement, so it's not organized, you know what it was.
Oh, yeah. So that's what I was, when I mentioned the lab, I think I mentioned that we would have to go back to the lecture 3, I believe. Let's see, 3.
Visual. Design.
Yes, that's a good question. So,
That's really key, the key variables in this.
oh, you're making them greater or equal to 0, non-negative? Yeah. Yes, I actually mentioned that in, yeah. Can you tell him? I will show you that. I will show you. No, if you just check that option. Yes, you check that option and then make them all greater or equal to 0, the decision variables. Lecture 3. Yes, so single period production problem right here.
Because I kind of did the same thing, I just kind of the equation.
Yeah, I see, and I see that. I mean, it would work. It will work. It will get, you will get the solution, but so this is the actual problem in lecture 3, the single period production model. And here's the data. So I basically created this table in the Excel file and set up the problem based on the formulation. So we have the formulation, which is basically what I shared with you here. So if we go to the Excel file, you get all that information in here. And then what I'm doing is basically pulling that information from the table to set up each constraint. So for the cutting, you are multiplying the needs per product. So X1 times 0.3, X2, which is goose, times 0.3, pence, which is 0.25 times X3, and gloves, which is 0.15 times X4. And the summation of that has to be less than or equal to 1,000. And then you do the same thing for insulating, sewing, and packaging. Actually, if you fix the decision variables, in this case, you can just scroll down and you will get the constraints 2, 3, and 4. But I don't want you to get confused. So that's the first constraint. Second constraint, they mentioned the same idea. Now you're multiplying the decision variables by the requirements for insulating. Constraint 3 for sewing, same constraint. And then for constraint number 5, you're looking at the inventory for each one of them. And constraint 8. The objective function is based on the unit profit and the penalty. Again, is the combination of those values and the decision variables associated with the profit and the unit penalty for those items that you cannot produce. So if we solve this, we can go to the data solver. You see that I made this is a maximization. The objective function is B12, which is located here. The changing variables will be all the decision variables. So if I go here, I'm selecting those 8 decision variables, that range. And then I have a so I have a constraint associated with each one of them. So one thing that can help you build these things faster, you can, if you have a group of constraints, if you have it set it up in this way and you have a group of constraints that are less than or equal to, instead of adding each one of them individually, you can just, let me delete them. So I'm talking about those less than or equal to. So you can just say, let me add these 4 constraints together. Those, all of them are less than or equal to. So I can just select them and then add them as a group. Okay. The equality constraints, yes, you can do that too. So you see now you have those, instead of adding them one by one, you group them and it will work the same way.
So would it be better, like, let's say in one of them, like you have a mixture of less than and then greater than, would it be better to do like all the greater than one and then all the less than probably equal?
Yes, so in that case, when you're inputting these things, it will be a lot easier. Yes, yes. So that's another thing that you can do. You group them by the sign, less than or equal to, equalities, and greater or equal to, and then when you select them in the constraints, you can just select them all together. So if we solve this, we get a solution right here. So these are the number of products that we are producing per type. So I'm going to click OK. So it's 800 for podcast, 750 for goose, 387.5. Again, the challenge when you get those fractional values is if you do 387 or 388 for pants, gloves 500. And then the only product that would carry a penalty based on this solution is the pants. 212 of those are not going to be produced. And you see, pants is now the lowest, doesn't have the lowest cost. And even though for the penalty, the one that has the lowest cost is $8. So you will think if I have to penalize one of those products, will be gloves most likely, but that's not the case. We are penalizing pants. We are basically saying we are not going to produce pants, and we're going to accept that penalty of $10 per pants that we are not producing. The reason for that is, as we discussed earlier, pants might consume more resources than gloves. So in that way, that it becomes more expensive for you to produce pants that produce gloves. So in that way, what the model is saying is, it's more expensive for you to produce pants. When you compare the penalty cost, it's better for you to accept the penalty for the pants instead of the penalty for the gloves. So this is the solution. Again, you will have to submit your model by tonight. So you can look at the video and see and confirm your solution using this strategy. I'm not going to release the file, but you can look at the values and how I set up everything. So you should be able to get the solution, same solution, and then upload the file by tonight. The other thing that I wanted to share with you, I was able to download the open solver. So if you are interested in learning how to set up that in your machine, let's discuss.
I have a question.
Yes, go ahead.
For the equals constraints, can you show what you did again, like in the actual what you?
Yes.
Like actually in the what did you put in the cell?
Let's see. Change. So for constraint 5, it will be the cell associated with that value, and then you select the equality sign, and then the right hand side, which is this cell.
Yeah, I mean like actually in the cell, not this part.
Oh, I'm sorry.
Yeah.
You're talking about the formalized cell.
Yeah, like
okay.
the formalized cell.
So it is the summation of the decision variables x1 plus s1.
Okay, and then what did you put in for the S? What did you put in for the slack? Formula and slack one.
Oh, the slack is just a decision variable. So
You just put it in there.
it's a changing variable.
Okay.
Okay, it's like x1.
Alright.
So you just when you set up the changing variables, you have to include the slacks. Yeah.
Because I got different, so I'm trying to figure out.
Okay, yes. So basically, when you look at the solver and you look at the changing cells, I'm selecting them all from x1 to s4.
Okay. Yeah, now I got it. That changes.
Okay. Yeah.
Now I got the same answer. I'm just trying to see where I was.
Yes. So remember, if they're decision variables, if they're considered decision variables, they need to be treated as a changing cell.
Okay.
Okay.
Yeah.
So let's look at the open solver. Just for your reference, this will be very useful for you maybe in the future, especially when you're looking at capstone design or senior design, I'm sorry, your capstone project. So I downloaded this from here. The link is available. Open Solver, I downloaded for my machine, Open Solver 2.9.3. So when you click there, you're going to get a zip file, this zip file that is right here. One thing that you have to remember, and if you don't do this, it's not gonna work, okay? You have to right click before you download or you extract the information. You have to go to properties and you have to select, let's see. Where is it? It's not showing up anymore. Let me do it again. I will download this again just to show you. So you download this. It's gonna take you to this site. You just wait. You don't have to click anything. It will download automatically. And then you go to the folder. And you right click, you go to properties. And yeah, here we go. So you have to remember before you extract the files, you have to remember to do the right click properties and you have to unblock the file. If you don't do that, this is not gonna work. Okay, so you have to unblock the file, click apply, and now you can extract the solver. So extract. Yes. And now when you click open solver here, Excel is gonna ask you to enable the macros. And if you go to data now, you should see the open solver right here. So it works the same way. If you click here, sorry, you will see that the window is very similar to the one that we work on. So you're gonna add the constraints, you're gonna put the objective function, the variable cells, and then we save the model. The nice thing about the open solver is that it's gonna highlight your model. So you can see the objective function is here, decision variables, the equations. If you don't wanna see your model, you just show hide model. And you can also solve it. If you solve it, you will see that you will get the exactly same solution that we got. But again, the open solver will allow you to solve larger instances of problems.
You don't have to go in and quick solve it. You could just quick solve it and then it'll go in and choose which one to repeat it. Is that correct?
Yeah, well, it shows.
Or do you think it will like?
Yes, you will have, because what it's doing right now is just pulling the information from the solver, adding from Excel.
Okay.
Since we already set it up, it would pull that information from there.
Okay.
But if you didn't have the model set up in the solver for Excel, you would have to create the model in the open solver.
So you create the formulas and then you can just put solve and it'll run.
Yes, so I mean, if you're working with the open solver, you forget about solver in Excel, you just go here and set up your model in this window.
Or you
Which,
still would have to set it up.
since we did it already for this problem in Excel, it is putting that information from there. But if you're working from scratch, you will not get the model.
Okay. So
You will have to go and set up everything.
okay.
Yes. Yeah, good.
How do you get to that page?
Oh,
Like a results page? So when we click solve,
Oh, yeah, yes.
when we click over,
Let's see.
and then the SQL reports, click. And click. And then example.
Yes, and there's another report that we're going to study, the sensitivity report, and we will talk about that one in the next weeks. Sensitivity, we need to learn some concepts first in order to understand the sensitivity report, but we will get to that one also. Okay, so I think we're done for today. So remember to upload your files, and on Monday we will work with Ample, and we'll go from there.
You said you'll put it sometime this weekend. download it.
Yes, yes. By tomorrow, I should be able to upload. I'm gonna upload the lecture, and inside the lecture, you will see the link to upload, to download the file. So this is done. So I'm gonna stop the lecture, and then we'll talk more on Monday.